Hey Cougars, today we're going to be working through notes 2.3. So do me a favor, do your quick review. So pause the video and answer this question. Okay, welcome back. Let's take a look. We have our ping pong paddle, okay, and it's going to hit the ping pong ball. So if I'm going to label this, so actually first let's draw our arrows. So we have one arrow pushing on the ball, and we have the other arrow pushing on the paddle. And this is when they make contact, when they hit here in the middle. Now let's label these. So this one is the force of the paddle on the ball. And then over here, we have the force of the ball on the paddle. Okay? So that's kind of the drawing we're working from. Make sense? Okay, so now we're going to go and look at the question again and make sure we've answered all the questions. Okay, so you hit a ping pong ball during a identify the action reaction forces. We did that. Which force is bigger? Be careful, it's a trick question. The forces should be equal to each other. Okay? So the force is the same. There is not one or bigger. Be careful. I will ask it like a trick question. Which force is bigger? And you're gonna be like, oh, it's this one. And it's no, the forces are exactly equal. Why do they move differently? Well, the paddle is attached to my hand, but the ball is not. So the ball is free to move, so it responds differently than the paddle. It has to do with net force. All right, let's continue. Let's go ahead and look at today's lesson, 2.3. Write in your learning intention. I can use Newton's second law to relate net force, mass, and acceleration. I can use Newton's second law to relate net force, mass, and acceleration. Now, we haven't done video notes in here before, so just as a reminder, pause the video if I go too fast, write down what I'm saying. Please know that I will be adding some things that may or may not be in the notes. So I'm not going to wait for you to write things down. Just hit pause. If you have to go backwards and rewind, please do so. If you may also turn on closed captioning, and you can turn on translate if you need to translate this to another language. All right, here we go. So first, we're going to talk about the general relationship between force, mass, and acceleration. We're going to look at how changing one affects changes in the other, and then we're going to learn how to do our 7-step process. So Newton's second law. Isaac Newton discovered this law, basically doing something similar to our lab, and he discovered that the net force is equal to the mass of the object times the acceleration of the object. In other words, the net force is equal to its mass times its acceleration, and there you go. So now let's take a look at what that means and what we saw in our lab. So look at this. If the net force is 24 newtons, so this is like the hanger that we used in our lab, the force doesn't change. So you can see that over here, the force doesn't change. But the acceleration over here on the right side it gets bigger as you go down. So for that to be mathematically true, what does that mean? What times 1 equals 24? Well, 24. Well, what times 2 equals 24? 12. 8, 6, 4, 3, 2, 1. Notice, as the acceleration gets bigger, the mass actually gets smaller. Notice that they're opposite of each other. That's really important. Okay? So while the net force is kept the same, as acceleration gets bigger as it increases, the mass gets smaller. It decreases. Or you could flip it around. If we flip it around, we got as the mass, if we go up, mass gets bigger, acceleration gets smaller. And that's what we saw in our lab. Now, how are we going to write this? See this F net with the equals and then MA? We're going to write symbols above this, and basically we're going to learn how to do math without doing math. That's basically what we're going to do. So in this case, the net force is not changing. So I'm going to come over here and see the equal sign. That's just a fancy up here on top of the letter. that just means that we're going to hold the force constant. That's not going to change. If the force is not changing, if the mass goes up, the acceleration must go down. If the force is held constant, if the mass goes down, then the acceleration must go up. Now, this is called inversely proportional in math. So this is called an inversely proportional relationship. So they're opposites of each other. Now, I want you to notice this. The ones that are opposites of each other, which side of the equation sign are they on? Same side? Or are they on the opposite side? So this is going to be a little silly, so listen carefully. If they're on the same side, they're going to do the opposite. If they're on the same side, they're going to do the opposite. And we're going to learn on the opposite sides, they're going to do the same thing. So they're opposites of each other. Okay, so inversely proportional. But what if I kept the car the same? I never changed the mass of the car, and I added weights to the end of the hanger. What's going to happen? As I add weights without changing the mass, the force is going to get bigger. So what's going to happen to the acceleration? Acceleration is going to get bigger. Okay? So don't make this harder than it is. So as net force increases and the mass is held constant, the acceleration increases. So look at this. If force goes up, but mass never changes, notice the things that are changing. Are they on the same side of the equal sign, or are they on opposite sides of the equal sign? They're on opposite sides, so they do the same thing. So force goes up, acceleration goes up. Force goes down, acceleration goes down. So opposite sides of the equal sign do the same thing. Same side of the equal sign do the opposite thing. Okay? This is called directly proportional when they do the same thing. So force and acceleration are directly proportional to each other. Forces cause acceleration to happen. Okay? So if the force gets big, the acceleration is going to get big. Force gets small, acceleration is going to get small. Now we're going to be getting into how are we going to ask this question on a test, and how are you going to be thinking about this? If I double the mass of an object, what will happen to its acceleration if the force is held constant? So we're going to identify what value is changing, what we're being asked about. So we're doubling the mass. So 2 times m. Okay. What value is held constant? The force. So we're going to put an equal sign. And then we're going to look at what we're asking about. So let's look at this. So I'm just going to show you. It's easier to explain this. So we write the equation. F net equals m times a. And actually, I would ask that you leave a little blank in front. See where the 2m is? Just leave a blank in front of that. But when you see it says double, you're going to write a 2 in front of the m. What does that mean? That means 2 times m. That means double. Does that make sense? And then I have a box here because I'm going to write how much is the acceleration going to change if this is double. Okay? And notice that I put an equal sign above the force because the force is not changing. So if the force is not changing and the mass gets bigger, what happens? Well, these two are on the same side. So this one got bigger, so this one must get smaller. Okay? So what number makes 2 go away and make this be the same equation it was when we started? A half. Because what's 2 times a half? Well, the 2's cancel. When we cancel, it's like 2 divided by 2 equals 1. What's 1 times 1? 1. What's 1 times 5? 5. What's 1 times mass? Mass. Okay? So if the force never changes, we don't want the force to change. So if I double here, I have to reduce this by the same factor. So I take the 2, write it as a fraction. So 2 over 1. So 2 2 over 1. And then I flip it, and now I write the fraction, 1/2 a. So 2 over 1, and then flip it, and now I've got 1/2. That's the short and easy way. That's the Mr. Franklin way to think about it, okay? So here we go. So when mass is doubled, the force is held constant, acceleration is halved. It's cut in half. Okay, that was a lot of words to say something that's really easy to do. So let's practice a couple of these. So example, if force is reduced to 1/3, how will the acceleration be affected? So we're gonna, got my pencil here. So if we've got F equals, so notice I'm gonna leave some space in front of my mass because we're gonna write some numbers, right? And then I'm gonna leave a space in front of my acceleration, and I'm actually gonna leave a space in front of my F. If force is reduced to 1/3, so I'm gonna take this and go 1/3 force. Do you see that? Force, 1/3. How will the acceleration be affected? So what are we asking about m at all? No, we're not. So we're going to put it equals above the m. Now, here's a hint. If they're on opposite sides of the equal sign, we got to do the same thing. So if this goes down by 1/3, guess what the acceleration does? The same thing. So it goes down by 1/3. Think of this like in your algebra class. If you do something to one side, you got to do it to the other side. The value of the expression cannot change. If that helps some of you with a little more advanced knowledge, the rest of us, keep it simple. If they're on opposite sides of the fence of the equal sign, so we could say that's a little fence. If they're on opposite sides, if I do it over here, it has to do the same thing. Okay? Okay. Let's do letter B here. If the mass is reduced to 3/4 of its original value, okay, so F. Are we changing F at all? No, we are not. So F is not changing. See, it's not mentioned anywhere in this problem. So we got mass to 3/4. So F equals 3 over 4 m, and then times A. So this is really simple. How do we do the opposite thing? We'll just take this and make it a reciprocal. Just flip it. 4/3. So if the mass gets smaller by 3/4, the acceleration is going to get bigger by 4/3. And think about it. 3 times m times 4 times a divided by 4 times 3. If you think about it, what's going to happen? The 3's are going to cancel, and the 4's are going to cancel out, and it's equal to F equals mass times acceleration. Okay? So bottom line, opposite sides of the fence, do the same thing. Same side of the fence, do the opposite thing. You try one, you try it, set it up, try it, pause the video. Okay, what does quadruple mean? Quadruple means multiply times 4. So how do we write 4 as a fraction? 4 over 1. So when acceleration is quadrupled, that means the mass, we got to flip it, must be 1/4. Okay, so we write the whole number as a fraction. So 4 divided by 1. And then we flip it, and that's our answer. So the mass must become 1/4 less. All right, acceleration is doubled. What will be the effect on the force? So we have m staying equal, 2 times a. They are on opposite sides. So what happens to the force? Got to do the same thing. And there you go. Okay, so the force must be doubled. Okay, so I'm going to go ahead and click off, show you the words behind the, yep, here we go. If you want to use those words from the slideshow, you can use those. Let me erase my writing here. Thank you for sticking with me here. Net force. So how does this connect to net force? Newton's second law only applies to the net force. So to find the net force, we have to draw a box and then use the arrows. The arrows represent the size of the force, and the arrows pointing in the direction of the force. We use positive and negative values to indicate the direction of the force, and we can only add arrows if they're pointing in the same dimension. In other words, If it's going side to side, we can only add side to side. If it's going up and down, we can only add up and down. Otherwise, we have to use much more advanced math, and we're not ready for that. So, for example, 30 newtons are applied to the right, 22 newtons are to the left. What's the net force? We draw our box. We draw our arrows. We already did this the other day. 30 plus negative 22 equals 8. Why is it negative 22? Because it's going to the left. Okay, 15 newtons are applied to the right, 70 newtons are applied to the left. Notice here the answer is negative 57. Should make sense. If one of those was up and down, we can't add them together. Not without way more math than we are ready for. Okay? Because it basically makes a triangle and things point in different directions. Pause the video, take a break for a second, and now let's go in and do second law 7-step problems. All right, welcome back. Solving second law problems. To solve second law problems, you can use the triangle method like we've been using. And so we're going to cover up the value that's missing and look for what we need. So here are the equations we could find. So if I cover up F net, here, let's see if it actually, no, it doesn't show us. So if I take my dealio here and I cover up F net equals M times A. So remember, if they're side by side, it means multiply. If I do this next one and I cover up the M, so I cover up the M, what's left? F net divided by A. And if I cover up the A, what's left? F net divided by M. So the triangle still works the same. It's just now we have different things in the triangle. Now, when we do this, the mass must be in kilograms or you can't use this equation. The force must be in newtons or you can't use this equation, and acceleration must be in meters per second squared. Okay, and all of that, if you need to review it, is in your vocab and your math vocab page at the beginning of your packet. Okay, so here we're going to do some 7-step problems. So first one, hockey puck has a force of 30 newtons applied. If its mass is 0.25 kilograms, what's its acceleration? So first thing we're going to do is we're going to underline our items and then label them. So we got force, mass, and acceleration. And then we're going to draw our box. Now, I told you earlier this week that we were going to change from a dot to a box, but we're going to write the mass inside the box. So here's the secret. Write the mass first, and then put a box around it, and now you have your box. Okay, so write your mass first, then draw your box around it, and now you have your mass. Then you're going to draw an arrow for your force, but acceleration also has an arrow, so you're going to have a second arrow. Notice, is there a here to there line in this picture? No, there is not. So this is a different thing happening. So we have a box with a mass of 0.25 kilograms, it's a hockey puck in this case, being pushed with the force, a net force of 30 newtons, and it's going to accelerate because it has a net force. So A is our question mark. We write our triangle, cover up the A, F net over M, write your equation, plug in with the units, plug it in your calculator, and you get 120 meters per second squared is the acceleration. Not too bad. Pretty simple. Now we're going to do one where this is one of the reasons why we always draw a picture, because sometimes we have to use the information in the picture to actually answer the question. So here we go. A skydiver experiences 700 newtons due to gravity and 500 newtons due to air resistance. And if they have an acceleration, what is their mass? So I'm going to go ahead and write my mass equals question mark, and I'm going to write it towards the middle because we're going up and down. If we're falling, I need to go up and down with my drawing. So mass equals question mark. Then I draw a box around it. Then I have my 700 newtons. Force Fg equals negative 700 newtons. Why did I put the negative? Exactly right. We're going down. And then going up, we have our parachute pushing up with 500 newtons. Oh, wait, no parachute. He's just falling through the sky. So the air resistance is pushing back on him at 500 newtons. And then we have another arrow, which is small arrow. Notice it's a tiny arrow, is acceleration equals -5 meters per second squared. So now we have our story. What's missing? Okay. Before we can do anything, we need to find the net force. So the picture tells us that there's more than one force. We got to add them together. They're in the same direction, up and down, so we can add them together. F net equals -200 newtons, which means now we can actually find our mass. So here's our triangle. F net equals m times a. So we're going to cover up the m because that's what's missing. And we're going to write the equation. M equals F net divided by A. So negative, then we plug in our numbers. -200 N divided by -5 meters per second squared, which should give you 40 kilograms. M equals 40 kilograms. That is the mass of our skydiver, so a tiny skydiver. You try. So this time, what I want you to do is go ahead and draw the picture. Don't worry about solving the problem. I want you to draw the picture. Let's focus on that first, and then we'll work through the problem. Okay? So M equals, that's a really big number, but you should write the whole M in the box. Acceleration is positive, so it's going up. And then net force, you should put a question mark. You put a question mark there. What's missing? Net force, question mark. A equals 15 meters per second squared, 15 M over S squared. Oh, disappearing ink. Interesting. And then M, yes, you have to write the whole big number, and don't forget the kg at the end. Okay? All right, you try this last one. Get it set up. Try to solve it as best you can. And check your answer. Okay? So practice setting up. If your drawing does not look like mine, you did it wrong. Okay, your drawing needs to look like mine. Don't forget to do your F net calculation because there's more than one force. So that concludes this video on 2.3. When I come back to class, we'll check and see how you're doing on this. And please check the homework because there will be some practice problems for you to do, and I will explain those directions in the next video. Thank you.